Your GPS doesn't know where you are. I know that sounds insane, but technically it's true. Your phone has no idea where it is. It just listens. And 20,000 miles above your head, a network of satellites is doing all the math and broadcasting the answer to anyone willing to receive it. That includes you. That includes your DoorDash driver. That includes every military asset on the planet right now. But here's what nobody tells you. The signal your phone gets and the signal a fighter jet gets are not the same. Today we're breaking down how GPS actually works, why civilian GPS is intentionally worse, and why entire wars have been fought over the ability to break this system. Let's go. A GPS stands for Global Positioning System. It's owned and operated by the US Air Force, not Google, not Apple, the Air Force. There are 31 active GPS satellites in orbit right now, sitting at 20,200 kilometers above Earth. Each one is broadcasting a signal constantly, a timestamp in its exact position in space. Your phone receives those signals and does one thing, measures how long each signal took to arrive. Since radio waves travel at the speed of light, if the signal took X nanoseconds to get here, your phone knows exactly how far away that satellite is. Do that with 4 satellites simultaneously, you get a position fix. That's called trilateration, not triangulation, trilateration. Yes, there's a difference. No, I'm not gonna let it go. With 4 satellites, you get latitude, longitude, altitude, and a precise time reference. That last one matters more than people realize. We will come back to it. Here's where it gets interesting. GPS satellites broadcast on 2 main frequencies. L1 at 1575.42 megahertz, that's what your phone uses. L2 at 1227.60 megahertz, that's military. The civilian signal is called SPS, Standard Positioning Service, accurate to about 3 to 5 meters on a good day. The military signal is called PPS, Precise Positioning Service, accurate to under 1 meter, sometimes under 30 centimeters, and it's encrypted. You need a cryptographic key loaded onto your hardware to decode it. Your iPhone does not have that key. Your drone controller does not have that key. A Tomahawk cruise missile does have that key. Now, here's something the government doesn't love to advertise. Up until the year 2000, the US intentionally degraded the civilian signal. They called it Selective Availability. They were basically sandbagging your GPS on purpose so enemies couldn't use it with full precision. Before they turned it off, because by 2000 the military had better ways to protect their advantage without crippling everyone else. That decision directly enabled modern ride-sharing, food delivery, precise agriculture, and drone operations we have today. Your welcome economy. Now let's talk about how you break it. GPS jamming is exactly what it sounds like. You broadcast noise on the same frequencies GPS uses, L1 and L2, and you drown out the legitimate signal. Your receiver hears static, it loses lock, your position disappears. Jammers are cheap. You can buy a basic one for under $50 online, which is illegal to use in the US, by the way. The FCC does take that very seriously. But at a military scale, Russia has deployed jammers that can deny GPS over hundreds of square kilometers. We've seen it over the Baltic Sea. Commercial pilots report losing GPS lock for extended periods near conflict zones. This is not theoretical. This is happening right now. The reason this matters for drones specifically, most consumer and commercial drones rely entirely on GPS for stability and positioning. No GPS lock, your drone does not know where it is. It either lands, drifts, or crashes. That's why military drones use INS, inertial navigation systems, as a backup. They track motion and accelerometers with gyroscopes and dead reckon their position, even with 0 satellite signal. Jamming is loud and obvious. Spoofing is surgical and terrifying. Yes, spoofing means broadcasting a fake GPS signal that's stronger than the real one. Your receiver locks onto the fake signal and believes it isn't somewhere it isn't. In 2011, Iran claimed to have landed a US RQ-170 Sentinel drone by spoofing its GPS, feeding it false coordinates until it thought it was home, and landed itself in Iran. Whether that's fully true is still debated, but the technique is real. Researchers at UT Austin demonstrated GPS spoofing on a yacht in 2013. They redirected an $80 million vessel without the crew realizing it at all. And today, there are reports of commercial aircraft near certain conflict regions suddenly thinking they're somewhere completely different. This is why modern military systems use multi-constellation navigation, not just GPS, but also Russia's GLONASS, Europe's Galileo, and China's Beidou, cross-referencing multiple systems to detect spoofing attempts. Your phone actually does this too now, but it's not foolproof. So let's recap what you actually learned today. GPS is a one-way broadcast system. Your device listens, it never transmits. Civilian and military signals are different frequencies with different accuracy and encryption. Jamming drowns the signal out. Spoofing replaces it with a lie. And the same system that helps you find a Starbucks is the same infrastructure holding together global logistics, financial systems, and weapons guidance. Which means the next time your Maps app tells you to make a U-turn into a lake, just know it could be so much worse. If you want to go deeper, I've got a full breakdown on SDR. I'm Allison, and I make electronics make sense.